So before I get the answer, I think I have one maybe video recording in my office from a previous class, but it might not be the same one. But let me do this one very quick, okay? So geometry, I'm just going to create, if you want the one for this one, 0, 120. Okay, I'll do this quick. Geometry, that's not the part that you need to know how to do. Alright, then I create the material property. 120 to the 9, 0.32. Okay, cancel. Property new. Give this value what to do. Shape, give me the values again for this one if you want. I can do anyone really, but I think the height was what? The 0.611 if I do meters. That was 0.324. 0.19 to the minus 3. 19 to the minus 3.
The width at the bottom is 13.
I don't know. And this is 321.
The width at the bottom is the same as the width at the top.
Oh, okay, yeah. This one can go to 321. So basically it should be the same cross section that we had before. You see basically the same values. Okay, cancel. Now do the meshing, mesh control, size around curve. I'm going to put 120. You can do more than that. I will do more than that if I was you. Okay. Now do mesh, geometry curve. I change this orientation. But I will ask if I can get tomorrow IT, because I have another computer. If I can get IT to come and install the Captivate again, and it works, I give you the link, okay? But I don't promise anything, because I've tried already. Okay, basically now, let's say we're going to do the one between, I don't have the exam, between 0 and 60 on the homework. What was the one on the homework? You have it open? Okay, doesn't matter, let's do. The first thing I will do is once you are here, in order to know the location, I will go and I will activate the work plane. Okay? Yeah. The work plane gives you the length. The first one goes from where? From 0 to
30 to 0, of course.
okay, but I want this to go 0 to 6, okay? So now you need to go, this is the important part. Model, load. Distributed loads are not nodal. They will always be elemental. Okay, so you need to go to model, you want to do the clicking, load, elemental. Alright, you click on elemental. You can put a title to the loading, just called loads, we'll just ask you once, click OK. And now you will go to the entity selection, enter element to select. I think the best way to do this is to go to pick on the window, go to box, and now you can click somewhere outside over here, and you keep it, you hold the bottom down, and you can go all the way to 60, but don't go past 60, stay right before 60. And now you will select all the elements up to 60, no? And you click OK. Now comes if you want the tricky part. Once you know how to do it, it's not tricky, but first time it is. You need to select distributed load. Now, this is not constant, so I need to go to here on the method. We need to go and click data surface. Once in data surface, you need to click here on the little square or table. And for me, the easiest one is to select the second one, between coordinates data surface. So you click here. And now you need to put the first point. So the load is going from which point to which point? It's going from 0, 0, 0. And what is the value over there?
1000.
1000 up or down?
Up.
Up, so about 1000. Okay? And this load is going up to which point? 60?
Yep.
About 60, 0, 0, and what is the value at 60? 0. And you click OK. Now, don't forget to do this at both ends of the element. Load A and B means basically at the end of the element. Each element has two ends, no? Beginning, first node, second node. So just put the same thing on the second one. And you should do it by itself, but if you want, you can put here 1. And make sure you select the same data surface for both ends. And you click OK. Now I will ask you for the orientation of the loading. You want that to be on the global Y or elemental Y. Should be the same in this case. And you do OK. Okay? And you should go here. I mean, I can do the next one. But otherwise, go and check. You should go from what? From 1000, which is 1000, all the way down to what? To 0, no? At 60, and what is that 60 would be 0.
Would you tell them which direction the load would be applied?
I mean, you told me positive, so this one is going up. If it's going down, you need to put minus. Yeah? Oh, one thing, since I've seen that stuff, because I've done it in purpose. If the load is going up, what should be then the equation to find the deflection curve? I didn't do a derivation, but if you have a distributed load, which goes down, here I think we wrote down that certain derivative of y dx was equal to minus m of x over ei, no? Yeah? But this is because this is going down. If the load goes up, what should be the sign then? If this goes up, what should be the expression? Should be e squared y x squared equal to mx over ei. Yeah? So be careful with that one. That might give you some. I mean, you will find out. It's not a problem. You will find out the value of the